Okay, a very good day and warm welcome to all participants to this webinar event. My name is Kanendra and I would like to thank everyone for joining us for the IEEE PES Malaysia webinar session. IEEE PES is a non-profit organization which gathers members who has power and energy related background with the objective to create a platform for exchange of ideas and knowledge. IEEE PES Malaysia chapter has managed to sustain its activity, which would span from knowledge networking, industrial visits, distinguished lecture series, and technical conferences. Today, we are most pleased to have our distinguished speaker, Professor A.N. Afandi from Universitas Negeri Malang, Indonesia, to deliver his lecture titled Orca Algorithm on Electrical Vehicles Inclusion in Economic Operation. Our moderator for this event will be Associate Professor Ayah Dr. Ahmad Farid Abidin, IEEE PES Committee member. I would like to also take this opportunity to invite participants to take part in our IEEE conferences, IEEE International Conference on Power and Energy, PCON 2022, and IEEE International Conference of Power System Technology, PowerCon 2022. Right before we begin our event, here's a short clip on IEEE Power and Energy Society. Right, thank you. With that, we would like to begin our event. I would like to pass this session to our moderator, Dr. Farid, Dr. Ahmad Farid Abidin. Thank you.
Thank you, Dr. Kanendra, and welcome to all participants, and welcome as well to our distinguished speaker, Prof. A.N. Afandi. Okay, today we are going to hearing the talk given by Prof. Afandi on the title of Orca Algorithm on Electric Vehicles Inclusion in Economic Operations. Before I pass to Prof. Afandi, let me give a short introduction to our speaker, Prof. Afandi. Okay, Prof. Afandi is a full professor who works as a senior researcher in the Electrical Engineering Department, EED, Universitas Negeri Malang, Indonesia. He received a PhD from Kumamoto University, Japan. He is now a senior member of Institute of Electrical and Electronic Engineer, who is currently charging as a chair for the Power and Energy Society PES chapter of IEEE Indonesia. His main experts is in energy and power systems, smart grid and hybrid system, intelligence and engineering computations. He is also interested in control and automated systems, power electronics, machinery drives, engineering education and applied technology, as well as green and orange technologies. Prof. Afandi has authored and co-authored more than 300 papers for journals and conferences. Okay, without further delay, I would like to call Prof. Afandi to deliver his talk. Prof, over to you, Prof.
Alhamdulillah, I'm fine. I hope so for you. Yeah. Okay. Thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you for inviting me to this great meeting for deliver and sharing about the Orca algorithm on the electrical vehicle inclusion in economic operation. In detail, I want to also thank for all the committee members for the IEEE in Malaysia, also in Indonesia. Thank you for collaborating this event. Also, all audience around the world is to join this meeting. I hope we can share and develop together and more than about not only sharing but also continue to other collaboration in perspective of our field. This is if I come to the Malaysia, maybe taking around 2 hours, 30 minutes. But now we are together in this screen to learn about our theme for this lecture. This is our about PES. Before concerning to my material, I would like to introduce about the PES in Indonesia chapter, especially. This is the one of the largest chapter in Indonesia, coverage for around 62 active members. So I hope this is encouraged for all candidate to join and to make a collaboration with us, and particularly maybe like one by one or person to person is important to mix some collaboration with match for the subject. Next, this is about our institution where I just for the 15. So we have 24 program study belong to the engineering faculty of Universitas Negeri Malang. They are covered for mechanical engineering department with 7 programs. After that, there are any civil engineering department with 4 programs. Also, me stay in electrical engineering department, coverage for 7 program. Another is industrial technology department with 4 programs. One more is a vocational program with 2 program. How about the electrical engineering department? There are serve for the education and pure for the engineering. So start from the diploma and then undergraduate and postgraduate. Maybe for the next time the doctor program will coming soon. So we are serve also for the doctor program. This is the office of my research, especially with power and energy system core for the world research spread for the harvesting like that in energy also, sometimes embedded in energy technology efficiency, automatic, and another related to the energy and power system. So we have I invite to all for join collaboration also. We provide also for the joint research or such visiting, so we can learn together at this office. So welcome for you all if you want to come in my office. Okay, please for you. Uh, Next, I want to start my presentation concern in this topic. Start with sustainable development tool from the UNICEF. This is to open our perspective how the energy still as the one of the concern in the United States, also in the Europe, also in Asia also. So based on the SDG, there are still affordable and clean energy. So this is very important to open and to share and how to expand, especially for technology and encourage another type for energy. This is very important because our country also needs energy to support development, not only for humanity but also industry and other aspects. This is according to the Global Energy Review 2021. We can see that the sophisticated for the renewable energy still leads. According to this figure, we show that solar, wind, and bio energy also hydro is rise to higher for the past year. It's been very important to develop the technology, also application of the renewable energy. Next one, this is how about the ASEAN capacity. This is the report of the ASEAN Power Grid, especially in ASEAN Power Update for the September 2021. We know that renewable energy also increase in these countries. We have to learn about many type from the coal, oil, gas, and hydro also, wind and bioenergy, solar, and other renewable energy. It means that the competitive for the water renewable is very important to expand and apply in our country to support the energy fossil base. Next one, how the energy, especially power, will be used in the end of the connection. So the infrastructure of our system is very important to establish until it can be delivered in good quality to the customer. So according to this structure, we know that power system has a main section like generation section, transmission, also distribution is follow very important to control in order to supply the demand. Based on the function, I think the generation is, as we know that the production for power, they are already existing, and that they will be transmitted and distributed to the demand as the final of the connection. But in this point, the in this point, the special case is how the enterprise can make production with cheaper production, especially less cost. So we have to reduce all the operating costs from the fuel or another operating factor. After that, also transmission and distribution operator is also very important. How to control in transmission and distribution in order to the power system is provide with high quality for the power delivery to the load or customer. So this is the very important also about how the behavior for the customer, because the energy will be used efficiently if customer also has a better behavior to energy consumption. This is the how the power delivery for for the power system. At the first point, the generating unit will be mix power production with suitable for the schedule of the power system. So this means at the generation sets will be decide for the possible combination between all of the power plant or generating unit. After that, how the transmission and distribution maybe makes some leveling for the voltage to deliver with reducing for the loss and improve the quality and improve the stability like that until it can be used in the various load at the final connection as the customer. So during 24 hours and 77 days, this is very important to manage in power station and how to manage the transmission and distribution certain make maneuvering to reduce the loss or another bad reset for the operation. After that, how to educate the customer is also important in order to it can be used energy in a good behavior to support all appliances. Next one is if we think about the delivery, so it not depend on the power consumption, but we also think about how the nature resource, especially for the energy conversion, because the conversion to the electric coming from the natural resource, not only from water, from gas on for coal or another aspect renewable energy. This is a very important how to the technology will apply to convert efficiently from the natural. After that, how to mix some generating units to, join together to support the power production until it can be distributed and in the transmission also. it's how the manage energy consumption. So this is very important. We should be managed in power station. Also after that, in operationally, transmission and distribution is also need to manage a better quality. After that, from the demand set, so we have to control and we have to manage usage. This is just very important in order to make a good and stability for the power stock. Next one is if we think the energy consumption, so we also think about the energy market, not only depend on the power generation, or in this case we call it the enterprise. So we have to there are any rates for the generating unit. After that, also in the transmission, maybe transmission and distribution has certain charge for the current on power flow at the connection. After that, we also think how the customer can buy energy. So this is the energy price that possible and accessible by a customer. So maybe there are any negotiable like charge, maybe like price also between energy enterprise and customer. This is very important to make some control and some negotiation between enterprise at the energy producer. After that, energy user also and customer has considered their capability to buy energy. So this is not only buy and sell energy, but there should be consider some negotiable charge, especially for the age rates between for energy enterprise and operator and energy user. This is some analogy for the enterprise, operator, and customer. How three parts can be collaborated in the power delivery, especially they will produce some power at the generating units. And they will spend some cost for the fuel for the maintenance and other that. So we will decide some rate for the power or energy. After that, if the operator is already to transmit and distribute the power, so we'll think about the operation charge for the system. So this is energy charge during the flowing for the system. After that, the customer will think about how to buy the energy, and then they have a capability to buy certain or amount energy, so they will select and they will decide for the energy price that possible uh, for the for the loan for loan from the customer. uh, Next one is how the power system access. So we will think we always think that the power system is only consists with generation to generate the power. After that, the power will be used at the final of the connection. So we think there are any load that connected to the system already and supplied by certain point to access of the energy. So we call that some type of load like industrial load, commercial load, domestic load, maybe agriculture and public or other type of the load. But if we think for the characteristic or based on the operational, based on the operating power, so we can think there are any big load like that, maybe average load, maybe base load. But if we think also from the characteristic or or power cost. So we know that there are any capacitive load, resistive load, and inductive load. Another type is we can think about the load or demand based on the static load and dynamic load, also flexible load. This is the final for the statement flexible load will concern in this discussion. This is the flexible load depend on the vehicle to grid. So we think that a vehicle will be have a role to the power system because the vehicle will charges by a system from the power station. So it means that flexible for the charge and discharge for the energy to the or from the system. So the vehicle is very important in the power system currently. So we think that this is the global sale for the market according to the EV volume and IEA. So we know that 21 is very increased contrast to global report for the electric vehicle also. So it's mean the electric vehicle also always increase yearly and yearly. So it's mean that we have to think how the impact in the power system operation, because each vehicle should be charged by a system. This is very important. So the flexible load is very important to the system now. Uh, this is the combination and how the power sharing can be supplied during 20 hours for 70 days. So we have to think how the power code portion for each generating unit, not only coal based or fossil based, but maybe another like renewable or gas also. So this is the important for thing about the power demand. Power demand is mean we should be collect all the possibility at the hours, especially how the power should be supplied for this. So all of them should be measured correctly. After that, we also think about the power plant, how the each generation or each generating unit can be combined and be or can be used at the combination at certain time to supply the power demand. After that, if there are any transaction or energy transaction, so we also think about how the rate of each other. So this is not only depend power, but now the power will transfer to the money measurement, especially the transaction. After that, the system should be operating under some condition, like technical requirement on environmental requirement. This is the condition of that it will be changed gradually during some certain condition. Next one is how periodical charge like this. Maybe the energy consumption depend on the charge, like enterprise rate, also operator charge, also energy rate. This is a factor how the maybe some time like certain time they are expensive, maybe another time cheaper. Is very depend on the rate of the operation. So it's mean very important to know that maybe the periodical for the charge not only change but also increase or decrease. After that, we also operating condition should be considered during operation in this point. Not only depend on the price system but also technical and environment. Now it's very important to control and to manage the power system based on the operation and non-operation limitation. Next one, this is maybe for the condition hourly change. Everything about the power demand, there are any base load like that overload, big load. So another, so we have to think about how to make a shifting to reduce the power production. So we have to load shifting. Another one is based on the power plant. So we think the first at the final for the connection at the energy user, other than at the uh, start connection at the generating unit. So we have to think the energy fossil based, maybe non-fossil based. After that, we also think about renewable and renewable energy. This is a more important thing about the power system, how the power should be produced and how the power should be absorbed at the appliances. So we mix a balance between loss of both of them. Now we think about power production during 20 hours. As I mentioned before, that we can decide from the power code for the portion of generating unit based on the sharing for the power production. So we have to think about the requirement also, customer is consumption behavior, also power production demand and market. This is a very important consideration for the power code portion. How to make power suitable combination is mean very important. Consider some like list cost strategy like that. This is some approach for the optimal realization, especially in the operating. So we have to think about list cost strategy like that. So we also optimal power production. Also, we think about optimal power transaction. In this case, is also export import is very important because there may be a vehicle. Uh, electrical vehicle can absorb and can discharge. So this is should be very important thing how to export, how to import. If some user or some customer will buy and will sell of the energy from the station. Another one we also think about renewable. In general, the optimization approach for the case for make optimal or plating in this we can use from the economic dispatch as we think about some certain limited time. How about the emission dispatch? We also think because now the environment protection also controlled by EPA. So we think during for 24 hours, it means will gradually change and gradually stock and gradually absorb. So it means the power system in economic dispatch will dynamically subject. So we have to change from the dynamic economic dispatch analysis. How to create optimal dispatching. This is a hierarchy to make function, especially concern to dynamic economic dispatch. The first point we have to think economic operation from the generating unit. So we think this is call for the economic dispatch. After that, we also think if the environment protection is very important to include in the power system. So we have to control the emission from the generating unit that use fossil base. So it means we are going to the emission dispatch. After that, both of them will under operation based on the some requirement like technical requirement or other operational condition. So this component should be matched at the function in dynamic economic dispatch. After that, how to compose between economic dispatch and emission dispatch, we have to add call in the dynamic penalty factor in here. But we can also use classical dynamic factor. But in this case, we introduce for the dynamic penalty factor. This is a different approach with penalty factor at the classical method. After that, we can use some tools to control, to search, to show for the problem. This is the early introduction. As I mentioned before, that the title is Orca. So I want to introduce for this is this Chan. As this presentation is early introduction to the world that Orca will compose on April X this year. So we introduce to audience that this is still the firstly introduced for Orca algorithm. So I have share to you about the how to the orca compose for here. This is the natural behavior for the orca. Orca is especially the top predator for the sea. So we can see this is the 14 behavior of the orca during in ocean, especially hunting for the prey. This is the hunting strategy for the orca. And around, according to biological report, some research report also that we can categorize in three type for the orca strategy during hunting the prey. The first is plucking strategy. After that, surfing seal strategy. After that, wave washing strategy. The third is very popular in the biological aspect or the oceanology. So in this moment, we have to concentrate wave washing strategy to make to create or to compose the Orca algorithm. The first point we have to think about how intelligent this fish The hunting activity cover for training and social learning between colony and different group of the orca, or even teaching. So this animal has some intelligence to training and to learning each other, and then to deliver information from the generation and to the next generation. So the orca is also has some intelligence to think about how the hunting strategy is very effectively to catch and to ambush the prey. Yeah, another one is the hunting present the orca culture to prey selection. This is an important thing that the orca has some intelligent mechanism to the ocean when getting the prey. Next one, how to adopt the Orca become Orca algorithm from the natural behavior and intelligence. So this is natural learning mechanism. So we have to learn some activity during the in ocean to get the prey. After that, how to get the intelligence for the process of this fish. We have to natural adoption innovation to get the some certain point to transfer in the computational model development. So we have some certain state to get the information from the orca fish. Next one is this is the modeling step during determining and during composing of the orca algorithm. The first point is learning for searching mechanism, because the orca will searching area of the prey. After that, we also have a second step, learning for the speeding mechanism. During the hunting process, the orca will control speed to get the various prey around their colony or their group. The third step is learning for embossing the mechanism. At the final target, the orca has a certain mechanism to get the prey. So this is three step during the composing of the Orca algorithm. So the first point, developing for selection phase and model. After that, the second stage is developing for speeding phase and model. After that, the final is developing for embossing phase and the model. So in this case, the Orca algorithm based on the three mechanism in the ocean. So we call in this algorithm has three phase. It means the first is selection phase. After that, the second is speeding phase. After that, the third is embossing phase. So before to the all of the phase, the first is very important, defining of all of the parameters that including in the computational. After that, we also develop hierarchy process from the all of the mechanism during the orca hunting process. After that, we have to make a computational sequencing that represents for the natural process into the orca algorithm. This is a three step for the orca modeling. Next one, how Orca algorithm model. This is the main model during the adoption of the Orca from the ocean. After that, we also include or inputs to the computation, and we have to three stakes, three phase, selection phase, and speeding phase, and embossing phase. All of the parameters during computation, we have two oracle number, wave factor, prey number, and hunting cycle. Another figure shows the flow chart for main process of the Orca algorithm to determine the solution of the problem. In this case, in this presentation, the early introduction of the Orca algorithm applied in the dynamic economies debate with electric vehicle. So in this model, we make a certain modified for the IEEE 62 bus system model. At the load center, we include the electric vehicle uh, as the flexible load. So at the point of the load, there are any charge station for the EV. So we have to think about include the power of the charging from the system to the vehicle. Next one, how to solve the DED problem based on the electric vehicle or EV. So this is the step for the whole of the combination during the problem solving. So we have to think about how all the parameter and data should be provided from the system and vehicle and another condition. After that, we also think about the system will be operated for 24 hours. It means under some requirement or like a technical limitation or environment condition. This is very important. After that, we have to make some function, objective function combined with all of the generating unit and all of the load between the EV and static also like that. So after that, we will apply Orca algorithm to solve the DED problem. In computational, we can use some many tools to get the program. So in this application, six subprogram designed for the data program like that. After that, system program. After that, problem program. So also include we Orca program. At the final for the last structure, we have to put for the output program. But we can make a spread each other, or we can make a one program. Is depend on how we can create all of the program. It depend on us how to include or how to split until a sub program like that. This is one of the sample for uh, performance of the Orca algorithm at the 8 o'clock, because this case DED is started from the 1 hour until 20 hours. So I have to catch at the 8 o'clock like this. This is the performance for the Orca algorithm, especially fit from the computation. And then we can get some statistically. We have to like average point, maximum point, optimal value, and other. This is a characteristic for the computational of the Orca algorithm. Next one, how about the EV, especially electric vehicle? This is the thing proposed in this analysis. In this case, at the first application for the Orca algorithm, we have to make a characteristic during 24 hours, especially work on business and study, another web service and shopping and research and other purpose. There are different characteristic for the activity. So in driving purposes, we should be think about how the electric vehicle will be used to support their activity. So at the in the morning, the work and business study is very higher. So the basic time depend on the work. After that, everything about the shopping. So the shopping will be around like maybe 1 until 2, especially there are increase until peak for the 12 day until at 2 p.m. This is a characteristic behavior using of the electric vehicle. So we call that this information say how the electric vehicle used for the activity. Next one is pattern. Tapping pattern is mean how the electric vehicle will be used for their activity. Maybe the first we only drop, after that we can cut. So we have two type of the driving pattern. The first is to trip. After that, they are one way. It mean maybe they going only or they coming home only. But as two trip, we are like going and then we're coming back to the first point. So we think about the electric energy. Electric energy inside of the car will be expand, will be used until there are empty, especially empty at the batteries. So to control the battery still in healthy, not all of the capacity battery will be discharged to the mechanical of the tire. So it is very important. So in this point, we put for this case with 80% operation for the batteries. So the battery has 20% of the power stock before all of the battery will be decreased until zero of the capacity. Next one, this is the characteristic of power consumption during 24 hours. Depend on the two trip and one way. Uh, Both of the characteristics depend for the power consumption. Like we can see in this figure, we have to depend on the between certain time until final. This is a characteristic everything the different pattern from the two trip and one way. How about the number of the power fitting to the electric vehicle? This is the number for 24 hours during the uh, uh, different pattern based on the activity like uh, morning on day or until night. So we have to number. This is a number of the EV. After that, we also think during for 20 hours. It means that two trip has higher for the one trip. It means that many electric car, electric vehicle should be charged for the two trip. This is another type for the non-EV load profile. As I said before, that 622 IEEE 62 model include with EV as the flexible load, but there are only a study only include for in this model. So the first point, we consider the first load based on the first point of the data for the 62 model. So we can manage for the non-EV load like this figure. Another one is this is the economic performance based on the TET case. We think about some performance depend on the hours during first hour until 20 hour. The total cost is mean the total from the operation of the generating unit depend on the power portion of this condition each time. For at the final is EV, so we have to think about the cost from the generating unit. After that, we also think of the EV for the power consumption during existing for the 24 hours. Okay, I think like that my sharing for us. Thank you very much, Dr. Farid. Thank you all. Wassalamualaikum warahmatullahi wabarakatuh.
Okay,
Okay.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. So we open any question from the participant. The Canada, is there any question from participants?
Haven't yet.
Yeah.
Okay, Prof. I think I would like to ask you a few questions regarding the patterns of the load on the basis of the EV. How you obtain that data? Is it from Indonesia or from where?
Yeah. No, we have two type for the data. And the first point, we as I mentioned that this study use IEEE 62 pass. So I have already data for the standard in this mean. So we combine with random of the load chain, especially for between load pass. After that, we have various load for the each pass, especially for load pass. After that, we also include the EV load as the flexible load from the electric vehicle. So we can use many data from the result, many results we can take. Some others use data, and then how many in the vehicle we find, and we put the random, especially random to control and to make the driving pattern. So it means we have the first point, we have the data from the IEEE 62 model, especially for the system. After that, we also completely with the data as the first for the static load. After that, we also make another data for the electric vehicle. So we have EV should be included at the load bus. It means there are any port for the power station, especially for charge station for each EV at the load bus. So this is combined for the first point standard for the I662 model. After that, we also make a data with a random to put and to make for the driving pattern for the electric vehicle. Yeah, like that.
Okay. All right.
Okay.
Okay, thank you, Prof. I think we have I think a couple of questions from the participants. I'll show the first one.
Okay. Question from Muhammad Faisal. Does the study on duration of the driving pattern include the charging time of the EV? Okay. Charging time will be dependent on the type of charger and size of battery. Did you get
Yeah.
the question?
Yeah, okay, thank you. It's good question for Mohammed Faisal. The first point, we have to think that the driving pattern, it's mean how the car will be completely for the road, especially there are any capacity for batteries during traveling for the car. We will spend for the like watt per kilometer like that. So this is depend on the batteries is also like that. So we think how the long road will be get for the completely. So this is very important. If we think the batteries will be empty, will be empty for the next road, so we should be think about this is the first charge. So we think the completely for different driving pattern depend on how long the road will be completely to the travel. After that, how the time is very, yeah, it depend on the charging speed, especially charging capacity. There are any current, any voltage. So how the charging is fully is very depend on the voltage and the current. So it's mean battery size. If higher size for capacity, they will be taking a long time for the fully charging like that.
Okay. Any more question?
Yes.
Uh, from Anggoro. Okay. Prof.
Yeah.
Andi, why do you choose the behavior of orca as the basis of your algorithm? Why do you choose behavior of other predators?
Yeah, okay, thank you. It's good question. Thank you very much for Anggoro. Yeah, how I choose the orca, we as I said before that the orca has some intelligence during the hunting, and then they can transfer and I mean, they can teach or they can deliver the information to the other generation. So it's mean during the hunting, they make a certain technique and deliver the technique. It's mean we have to learn. So as the colony, as the group for the orca during the hunting process, they transfer and they teach and they together learning to take or to embrace the prey. So it means very important to think there are any certain mechanism intelligently in the orca. So I think this is very important at the inspiration. How I think this is it can be adopt to the computational intelligence. So the orca is very specific, well, especially at the predator. In the ocean, the orca placed on the top of the predator. So they are only maybe they will dead after completely of the egg, especially at the cycles for the orca. They will birth. After that, they will grow up. After that, they will develop baby again. After that, they will die like that. So this is very important, and then this is very curious to adopt the orca because they has some intelligently during the during the getting prey for the like eating and like like eating, maybe like provide for the food their baby like this. So this is very important. So I think Orca has a certain thinking about something in the mechanism for the hunting process ocean, because all of the not all animal has intelligently like this, and a certain mechanism delivery to the generation and next generation. So it's very curious to adopt after innovation for the computational intelligently. So this is a very important and main point of this orca is there are any intelligently process for this. So we have to think about it can be applied in the another aspect of the computational. So Orca, I mean, the name is also, I still put the Orca algorithm as the Orca, not Orca, the top whale or killer whale, but I transfer to the Orca algorithm like that. Thank you.
Okay, thank you.
Okay. Okay, again, from Muhammad Faisal, okay, does the study also consider the availability of the nearest charging station during the driving pattern? Most countries do not have sufficient infrastructure for EV charging facilities.
Hello. Yeah, thank you. Thank you, Makam Faisal. In this study, we do think we don't consider about the how the charger station is, especially for how the fast for the charge station. But we think in this study we only consider about the time for the charge depend on the battery's capacity. But we don't think about we don't consider about the near or closer the power uh, uh, charge station for that. We don't consider this, but we only consider for the battery's capacity depend on the route's length, especially for road plan. So how far the route will be completely depend on the capacity of batteries. So if there are still close to the 80%. So as I said before that the batteries will be limited by 20%. So batteries already has a stock 20% of capacity, because this is for keeping the batteries healthy. So we control with 20 capacity. Why 20 capacity is depend of us, but some batteries not only capacity, it can be charged also. But in this study we control of battery capacity only 20%. So before each battery loss of the capacity, it must be charged, not depend how close and how far of the charge station, but we only stay in this mean all of the power station at the load bus, we there are already for the installed with charge station. So in this study we didn't consider for the close or charge, but only limited by the battery's capacity. But for another aspect, it can be included. But we in this bubble we can include many parameter, we can include many requirement also, but it depends our purpose to do our purpose to do like that. So we can maybe this important if we think optimization about how fast for getting the charge, so we can put the distance of the charging station. If there are any charging station closer, so we will take fastly like that. Maybe we think about the distance of the charging station. But in this study, if I present for us, not consider for the closer or far for the charging station, but the capacity only limited by 20% of the capacity in battery. So if we depend of the driving pattern, also depend on the battery's capacity. Thank you.
Okay. So that's mean there is a lot of parameter that we might consider for the
Yeah,
potential
yeah,
study for the
absolutely.
research.
Yeah, it's good.
Okay. Okay. Do you have any more question? Perhaps one more question.
I think that's about it. I think those are the questions that are correct.
Okay. Okay, Prof. Just final question from me.
Yeah.
Uh, on choosing the bus which connected to the EV. So how do you choose it? Is it for every bus or the certain selected bus
No,
for the EV
yeah.
charging?
Yeah, okay, thank you. How we choose the bus for the EV? So this is the EV also depend on batteries charging station. There are some parameter for charging is voltage charge. So we have to think there are any equality for the voltage charge between batteries and bus station. Especially bus station, it means there are installed for the charging station. So we mix certain some other from 3 kV, some other from 6 kV, depend on the charging system. So if there are any like a medium voltage system, so we can use charge like that. Maybe some other already at the low voltage system, they are maybe increased by transformer. After that, combined with AC and DC converter because batteries is DC. Maybe another also if we discharge to the system, they also charge in the system. So we have to think about that. So not only directly from the system, we have to think about the battery capacity for the voltage during the charging. After that, how the system provide for the voltage that's suitable for the charging station. So this is some mechanism or some aggregate to make suitable for the charging station from the system. So this is very different with another load, static load like that, because there are AC load. This is a DC load with a flexible mobility is very easily. So we provide the power station from the system. After that, power from the power system will be transferred to the charge station. So there are provide for DC like that. Thank you.
Okay, thank you. Any more question, Dr.
Mm,
Kanendra or
yeah,
Professor?
I think that's all.
Okay, I think we are already at the end of this our
Okay.
slots. So thank you so much, Prof. Andy, for very
Thank
interesting
you.
and it's very informative sharing with us. So over to you, Dr. Kanendra.
Okay, thank you, Dr. Farid. So
Thank
I'd like to take this opportunity to thank Professor Effendi for his very interesting talk, and also Dr. Farid for moderating this session. And I'd also like to thank all participants who have joined us to view this webinar session and also to ask questions. So further questions, if you have, you can directly direct to Professor
thank you.
Effendi. Okay, it's email address to his university. And with that, we'd like to thank everyone again till we meet for the next webinar session. So thank you.
Okay, thank you, Prof. See you again.
Thank you,
Okay.
everyone. Thank you.